Hi, my name is Jonathan Kim again. This is the book that we'll be using. It's called Advanced Mathematics by Brown, and we're going to be doing Chapter 5, Section 3, starting on page 184, numbers 14 through 20 even. I know you guys are having a little bit of tough time on these, so that's why I'm trying to help you out. Okay, so let's get started. Number 14 says something like this. A bacteria triples every 4 days. The population is P naught. P naught is the initial amount. What will be the population of P of t after t days? So the function is going to look something like this. Because the triples, population a function of time t, population as a function of time t is equal to P naught, which we don't know, times, instead of 2, it's going to be triples to the t over half-life, which is 4 days. So the final answer, after t days, what will it be? P of t is equal to the initial amount times 3 to the t over 4. I didn't do this one. Okay, that's t over 4. Number 16. When a certain medicine enters the bloodstream, it gradually dilutes, decreasing exponentially with a half-life of 3 days. The initial amount of the medicine bloodstream is A naught milliliters. What will be the amount after 30 days? So it has a half-life. So that's a key word, half-life, which means it's going to look something like this. P of t is equal to A naught times 1/2 to the t over the half, how long it takes to dilute to half amount. You can use P of t or you can use A of t, it doesn't really matter. The amount that's left, P usually stands for population, A stands for amount that's left, it doesn't really matter. Your A naught is still your A naught times 1/2. So after 30 days, this will be 30 over 3. So 3 over 30, 30 over 3 is going to be 10. It's going to be A naught raised to the 1/2, the 10 power. That's equal to A naught times 1 over 1024. It's going to be 1 over 1024 amount that's left of A naught. By the way, I'm going to do this on my calculator. 1 divided by 1024, it's going to be point 0.0012349765625 A naught. Not much left after 30 days. Okay. Number 18. It's a little bit tricky. So let's try 18. Let f of x is equal to 2 to the x right over here. Complete the table. So here's the table. X, -2, -1, 0, 1, and 2. And here's f of x. And you want to figure out what that is. F of -2 is equal to 2 to the -2 power. If I go 2 to the -2 power, because of this negative, you do not bring it down to the front. That's the same thing as 2 to the second power, 1 over that, right? So 1 over 2 to the second power is 1 over 4. Likewise, 2 to the -1 power is equal to 1 over 2 to the first power, which is 1/2. 2 to the 0 power, 2 to any number raised to 0 except for 0 itself, 2 to the 0 power is 0. What am I saying? 1. And then 2 to the first power is 2. 2 to the second power equals 4. And that's part A. That's part A right there. Part B, we're going to graph it. At 0, it's going to be 1. At -1, it's going to be 1/2. At -2, it's going to be 1/4. At 1, it's going to go up 2 units. At x equals 2, my y value is 4. and it's going to look something like this. Notice that this is called exponential growth because the variable x is at the exponent. That's why it's called exponential growth. Okay, as opposed to y equals x squared. Notice that the variable is at the denominator or the base, and the exponent is just a number or coefficient. Here, the variable, notice that it's a lot different than x squared, which is 2 to the x. So it's called the exponential function. We plot it. Explain why f has an inverse. The reason why we know that f has an inverse is because it passes the horizontal line test. Any horizontal line that you draw only passes through one point. And so we know that if it passes the horizontal line test, then it has an inverse function. Graph f inverse of x on the same set of axes. So we're going to try to draw that with a different color pencil this time. Let's use, I don't know, orange. At 0, 1, it becomes 1, 0. At 1, 2, it becomes 2, 1. 2, 1. And at 2, 4, you have to reverse the x and the y. That's how you do inverse functions, right? Replace the x and the y. It becomes 4, 2. And negative 1 half, negative 1, 1 half at x equals 1 half. My y value is negative 1. There it is. And then when x equals 1/4, my y value is negative 2. So here it is. And there's your inverse function. Notice if I use a blue line, and I use the y equals x line right there, it looks like it's a mirror image of that line, y equals x. Notice that y equals x, x and the y can be interchanged. Okay? So, that's it. Oh, almost. We got part D. That's part C. Oh, that's part D. Okay. Part E. Part C was because the function passes the horizontal line test. It also has one more thing. If it passes the horizontal line test, it's called the 1-to-1 function. Okay, so that's how you get that. Next, state the domain and range of f. I'm just going to do the domain of f is all real numbers because x can be anything. You can put in x, any number for x if you want here. So for f, the domain is all real numbers. I don't know, some teachers like to write it this way, to infinity. That's called all real numbers. Okay. And the range of numbers is anything above the y-axis, because if you take this function right over here and then you plot it along the y direction, it's going to go anything above 0. So y is greater than 0, or you can say parentheses 0 to infinity. Okay. And then you just reverse it for the domain and range for your inverse function. Okay, so your domain becomes your range, and your range becomes your domain. Okay. Next question, last question, number 20. Number 20 says graph y equals 4 to the x and y equals 4 to the x over 2 on a single set of axes. How are the graphs related to each other? So what I'm going to do is I'm going to call this y1 and y2. X, y1. Negative 1, negative 2, negative 1, 0, 1, 2. When x is negative 2, 4 to the minus 2 power is 1 over 4 squared, which is 1 over 16. 4 to the minus 1 is 1 over 4. 4 to the 0 is 1. 4 to the 1 is 4. 4 to the second is 16. Let's graph the second set of axes, x and y2. -2, -1, 0, 1, 2. So these are the numbers that usually start off with when you're doing, you start off at your center and it goes up exponentially and it decays here in this direction. -2 over 2 is going to be -1, it's going to be 1/4. -1 is going to be 4 to the minus 1/2. It's going to be 1 over 4 to the 1/2, which is going to be 1 over √4, which is 1 over 2. 4 to the 0 is 1. 4 to the 1 is 2. 4 to the, I'm going to do this one more time. Do this one more time, okay? 4 to the 2, no, 1 over 2, right? That's your x value right there. So if you change this into, this is called exponential form. If you change it into radical form, it's going to be 4, and the index becomes the outside denominator, becomes the index, and the numerator becomes the power. And the square root of 4 is 2, so the 1 is 2. 4 to the 2 is going to be 4. So -1, -2, 1, 2, 1, 2, 3, 4, 1, 2. At -2, it's going to be 1/16. -1 is going to be -1/4. 0 at 1 is going to be 4, and then 2 is going to go way up. So it's got a pretty steep exponential because of this 4 right there. Let's graph y2. At -2, it's going to be 1/4, not quite as much as 1/16. It's going to be 1/2. It's going to go to the same point at 1. It's going to go up 2 units instead of up 4 units. Sorry, it's going to be here. No, not that one. And at 2 is going to be 4. So when we compare it, when it's like a fraction, 1/2 of x, it's going to be even flatter. If it's going to be like the function y3 is equal to 4 to the 1/5 x, it's going to be even flatter. It's going to be something like this. Okay. But it's still going to, in the end, it's still going to go up really high. Got it. So hope it helps. And if you have any questions, just put a note on the video, and I'll take a look at it. Thanks. Bye.